Everyone thought Mercedes had the upper hand after the first race of the season. The straight-line speed looked unbeatable. The energy deployment looked perfect. And many engineers believed Ferrari would need several races to catch them. But just before the Chinese Grand Prix, everything changed. Because Ferrari revealed a radical upgrade on the SF26 that forced the FIA to step in and officially confirm it was legal. And the moment that confirmation came, the entire paddock realized something shocking. This was not a normal update. This was a completely new aerodynamic weapon. A rotating rear wing system so extreme that some engineers believe it could deliver up to 10 km/h of extra top speed on Shanghai's massive straight. And if that number is real, Mercedes suddenly has a serious problem. Because the car that dominated the straight-line battle in Australia might no longer be the fastest machine on the grid. But here is the part that made rival teams nervous. Ferrari did not arrive in China with just one version of this system. They brought 3 different specifications. 3 different aerodynamic configurations. All built around a concept that changes the entire behavior of the car between corners and straights. Which raises a question that suddenly has the entire paddock watching Ferrari very closely. Did Ferrari just introduce the most dangerous aerodynamic idea of the 2026 season? Or did they just expose a concept that the rest of the grid might need months to even understand? So before we break down the upgrade that shocked the FIA, the radical rear wing system Ferrari unveiled in China, and why Mercedes could suddenly be in real trouble, make sure you subscribe to the channel. Because what Ferrari has just revealed might completely change the direction of this Formula One season. Right after the Australian Grand Prix, Ferrari's engineers returned to Maranello with a very specific concern. The SF26 was competitive. In fact, during several race stints in Melbourne, the car showed very strong traction and excellent race pace. Charles Leclerc finished on the podium, and Lewis Hamilton was fighting near the front despite strategic issues during the race. But when the engineers began analyzing the telemetry, one weakness became impossible to ignore: straight-line efficiency. Compared to Mercedes, the Ferrari was losing speed on long straights. Not dramatically, but enough to make overtaking and defending far more difficult during race conditions. And that difference becomes extremely important on a circuit like Shanghai. Because the Chinese Grand Prix contains one of the longest straights in Formula One. Cars exit the slow hairpin and accelerate for several seconds before reaching the heavy braking zone at the end. If a car loses even a small amount of speed during the first part of that acceleration, the gap multiplies along the straight. That is exactly what Ferrari engineers wanted to fix. Originally, the team planned to introduce a major aerodynamic concept later in the season. But after seeing the early performance gap against Mercedes in Australia, Ferrari made a bold decision. They accelerated the development schedule. Instead of waiting several races, they brought the concept directly to the Chinese Grand Prix. And the centerpiece of that decision was something the paddock had only seen briefly during earlier testing. The rotating rear wing system that engineers began calling the Macarena. This was not just another rear wing upgrade. It was a completely new mechanical and aerodynamic interaction. Unlike a traditional rear wing where the angle changes slightly, the Ferrari design allows the main plane of the wing to rotate dramatically around its axis. In cornering mode, the wing behaves like a normal high downforce rear wing. It generates strong aerodynamic load, helping the rear tires maintain traction when the car exits long corners. But the moment the car reaches a straight, the profile rotates. The wing flattens dramatically. And the aerodynamic drag drops instantly. That change allows the SF26 to slice through the air much more efficiently, increasing top speed along the straight. The engineering challenge behind this system is enormous. The rotating structure must remain rigid enough to satisfy FIA legality tests. The actuators controlling the rotation must operate with absolute precision. And the transition between cornering mode and straight line mode must happen at exactly the right moment so the driver does not feel sudden changes in balance. That is why Ferrari spent months discussing the concept with the FIA before receiving approval to use it. Eventually, the governing body confirmed the system complied with the regulations, allowing Ferrari to bring it to China as a fully legal aerodynamic component. But the design itself is only one part of the story. Because the real advantage of the system appears when you look at how it interacts with the rest of the car. When the rear wing rotates into low drag mode, the diffuser and beam wing underneath the car continue generating aerodynamic suction. That means the car does not suddenly lose rear stability on the straight. Instead, the aerodynamic load is redistributed. The upper wing reduces drag. The lower aerodynamic structures maintain enough stability to keep the rear axle planted. This balance allows the car to remain predictable for the driver while still achieving massive drag reduction. And this is exactly where Mercedes may face a serious problem. because the Mercedes package built its early season strength around straight-line efficiency. But if Ferrari can now match or even exceed that efficiency while maintaining stronger traction in corners, the competitive balance changes immediately. And what makes the situation even more intriguing is that Ferrari did not bring just one version of the system to Shanghai. They arrived with 3 different specifications of the rotating wing. A higher downforce version with a more conservative rotation range. A balanced specification designed specifically for the Shanghai layout. And an extreme configuration capable of rotating almost 270 degrees to minimize drag as much as possible. That flexibility means Ferrari can adapt the concept depending on wind conditions, tire behavior, and race strategy. But the most fascinating part is what rival engineers started asking themselves once they realized how the system works. Because this upgrade is not just a component. It is an aerodynamic philosophy. And that raises a question that could define the entire championship. If Ferrari has already unlocked this level of aerodynamic efficiency at the second race of the season, what happens when the rest of the development program begins to build on top of it? But the real impact of Ferrari's upgrade becomes clear when you look at the circuit where it debuted. Shanghai is not just another track on the calendar. It is one of the most complex aerodynamic challenges in modern Formula One. The lap begins with the famous spiral corner, a long tightening turn where drivers carry steering input for several seconds. The front tires are under enormous pressure, and the rear of the car must remain stable as the driver gradually applies throttle. Then comes the contrast. The long back straight. One of the longest full throttle sections in the entire championship. And this is exactly where Ferrari designed the rotating wing to become devastating. As the car exits the final hairpin before the straight, the rear wing works in full downforce mode. The profile is steep, generating strong aerodynamic load that helps the rear tires grip the asphalt. That traction allows the driver to apply throttle earlier than rivals. And in Formula One, those first meters of acceleration are everything. But then, the moment the car straightens and reaches the defined activation zone, the system transforms. The wing rotates. The aerodynamic profile flattens dramatically. And the drag that normally slows the car at high speed almost disappears. Suddenly, the Ferrari is not pushing against the air anymore. It is slicing through it. This transformation allows the car to accelerate more efficiently along the straight, gaining speed without needing to deploy excessive electrical energy from the hybrid system. That detail is extremely important. Under the 2026 regulations, managing battery energy across a lap is one of the most difficult strategic challenges for teams. If a car can achieve higher straight-line speed using aerodynamics instead of electrical power, the driver can save battery energy for other parts of the lap. That means stronger acceleration later. Better overtaking opportunities, and more flexibility during wheel-to-wheel battles. This is exactly why engineers believe Ferrari's concept could be so powerful. The rotating wing does not only increase top speed, it changes how the entire energy management strategy of the car works. And that could put Mercedes in an uncomfortable position. Because the Mercedes car has been extremely efficient in how it deploys hybrid power along long straights. But if Ferrari can now match that speed while using less electrical energy, Mercedes suddenly loses one of its most important advantages. Even more interesting is how the system behaves when the car approaches the end of the straight. Just before the heavy braking zone, the wing rotates back into high downforce mode. The aerodynamic load returns. The rear axle becomes stable again. And the driver can attack the braking zone with confidence. This transition must happen perfectly. If the wing closed too late, the rear of the car could feel unstable during braking. If it closed too early, Ferrari would lose some of the drag reduction advantage on the straight. That is why the synchronization between the wing rotation and the braking phase is one of the most critical aspects of the system. And according to early analysis, Ferrari has spent enormous effort ensuring that this transition feels completely natural for the driver. Which explains why the FIA spent so much time evaluating the design before approving it. The rotating structure must remain rigid. The actuator system must operate within defined positions. And the system cannot behave like continuous active aerodynamics. Instead, it must function with clearly defined modes, similar to an advanced version of the old DRS concept. Once those conditions were verified, the FIA confirmed the system was legal. And that moment changed the entire technical conversation inside the paddock. Because once the concept was approved, every rival team immediately began asking the same question. How long would it take to build something similar? And the answer many engineers arrived at was not encouraging. This is not a simple wing redesign. To replicate the system, teams would need to redesign the rear aerodynamic structure of their cars. The mounting points. The actuator mechanisms. The interaction between the wing, diffuser, and beam wing. and the airflow behavior across multiple phases of the lap. That kind of development cannot happen overnight. It requires months of wind tunnel testing and simulation work, which means Ferrari may have created a window of opportunity. A period where the SF26 possesses a unique aerodynamic advantage while the rest of the grid tries to understand how to respond. And that is why some engineers inside the paddock describe the Chinese Grand Prix upgrade with a very dramatic phrase. Not just an update, a statement. A signal that Ferrari is ready to challenge Mercedes much earlier in the season than many expected. But this is where the story becomes even more intriguing. Because the rotating wing is not the only change Ferrari brought to China. Hidden within the rest of the SF26 package are several smaller aerodynamic refinements. And when those changes are combined with the new wing concept, they may reveal something even more important about Ferrari's development direction for the rest of the season.